Good morning, everyone. Welcome to today's maths class for grade 11. Welcome also to our new system, Teams. All of us are basically working around getting the hang of Teams. So I do sincerely apologize in advance if we have any glitches or alike, but the plan is not to have any. Just
Mbali, you muted yourself.
apologies for that, guys. So our rules mostly remain unchanged, but we've had some changes in our rules given our changing system and a minor change in how things work from here on out. Our first rule remains respect everyone, we are all here to learn. Our second rule, there's no such thing as a dumb question, so please feel free to ask. Number 3, please type your questions in the Q&A section. This is one of our new rules. Number 4, all questions that are typed in the Q&A session will be answered in the last 10 minutes. You guys, we are unable to interact as we were previously able to, and as such, I'm going to ask you guys to keep your questions, type your questions for me, and from there, I will be answering in the last 10 minutes. Again, this is an old rule. We will not tolerate vulgarity. Also an old rule. Please do not take the opportunity to learn away from someone else. The purposes of these classes is to benefit you guys across the board. And if you feel that you're not benefiting, please don't take for granted that someone else also isn't benefiting. Lastly, the link to the class will be posted in the Q&A section for use for another time for you. Right. So with today's lesson, mainly we are going through the examples. We got as far as the reduction formula last week. We've been working on the reduction formula. We've been working on the reduction formula using a theta, using a beta, using an alpha. So we will go back to our solutions, take those step by step for today, and then do a few more examples before we move on to double and half angles. Right. Guys, this is a quick recap from Friday. Do you guys remember that on Friday we built this, call it a presentation slide, where we tried to allocate or put into our Cartesian plane the different rules or the different identities that are associated with creating or using a reduction formula. There's some rules that we actually didn't get to, guys. I actually took for granted and thought of afterwards. There is the rule where you have a negative angle. So where we are saying, for example, your angle is sine of negative beta. Did you guys know that sine of negative beta is the equivalent of sine of 360 degrees minus beta? How we come to this conclusion? Remember, we had said that your Cartesian plane forms a revolution that starts at 0% all the way around to 0 degrees, all the way around to 360 degrees. At 360 degrees, that is basically your restarting point, the same point as 0 degrees. And so one would argue that in here is a 0 degrees, which means you've completed a full revolution, and now you are starting over. Again, this then will be expressed as minus sine beta. because there, as you can see, sine is negative in this quadrant, in the fourth quadrant. Right. The same is true when you have the other example we didn't do is in the instance where you have a sine, let's say 450 degrees minus beta. So a 450 degrees is basically made up of a 360 degrees and a 90 degrees. So yet again, in the first instance, you would have completed a full revolution, and so you have gone around once, you have gotten back to 0, so we can reduce this again to the sine of, apologies for the space issue, guys. Let's use it here, right? You can reduce this to the sine of 90 degrees minus beta. And then again, you will apply our usual rules where the sine of 90 degrees minus beta is equal to cos of beta. If anybody has any issues around this or any not understanding, please leave your questions for me in the Q&A and I'll be sure to attend to you. But yes, this is what we had built on Friday. We had built our Cartesian plane on Friday, which, guys, I'm not big on people cramming. I wouldn't want you to cram all the formulae in the Cartesian plane. I would just like you to have understanding, to have a relaxation around how it works, around understanding that your first quadrant is a 90 minus, or is just a beta in itself, and the 90, in that it's a 90 minus because here at this point is your 90. Remember that we had said on Friday that we are working with beta as an acute angle. Same is true here. In the second quadrant, you have a 90 plus and you have a 180 minus. Remember, I had said, look at this as if you are using a protractor. This is your 10 degrees, 20 degrees, etc. And so anything sitting this side, for example, would be 150 degrees, which can either be seen as 90 degrees plus 60, or that's when you would express it in this way, or it can be seen as 180 degrees minus 30, which will be expressed in this manner. And that is how you just know which quadrant of the Cartesian plane you fall in. Remember, I had said to you, how do we remember? We remember by saying a very smart trigonometry class. That was the rule I was taught, and I'm passing it on to you, just to remember which quadrant has the positives and which quadrant has the negatives. So from that, I will be going through our solutions from Friday's homework questions, our practice questions. I'll take it step by step. If you have any questions or you don't understand, please document your questions for me in the Q&A. We will get to that. Please also, when you do document your questions, please ask your question by giving a reference point of where your question is coming from, because we have quite a few questions to get through. Right. Here we go. Our first homework question was for us to simplify the following. So it said simplify 2 sine of 180 minus beta, cos of 360 minus beta, divided by the cos of 90 minus beta times the cos of 180 plus beta. So right away, we keep our 2. Our 2 is a whole number, and we will multiply with our whole number. We are multiplying because there is no sign in between here, which is either a plus or a minus. So there we will immediately keep our 2. And so from here we say 180 degrees is the second quadrant. Sine is positive in our second quadrant. And so we will keep it at sine of beta. Cos 360 minus beta. 360 minus beta is our fourth quadrant. From our fourth quadrant, we know that cos is positive in the fourth quadrant, so this will translate into a cos of beta. So let me say sine beta, cos beta. Right. And then Here we have a cos of 90 minus beta. So the moment we see a 90-degree angle, alarm bells should go off, ding, ding, ding. We have the COCO rule, where when we are reducing from a 90, we use the co-function. The co-function for cos is sine, and so we'll say sine, and sine is obviously positive in the first quadrant. Well, cos is positive in the first quadrant, and so it will be a positive sine of beta. Then we have our cos of 180 plus beta. 180 plus beta is quadrant 3. Cos is negative in quadrant 3, and so we will multiply by minus cos beta. Right? That is what our second step will look like. From there on out, quite simply, as you can see, this is multiplication. Cos over cos is 1. Please be very well aware this negative is still relevant. It still remains. Sine over sine is 1 again. So ultimately here, we are left with 2 times 1 divided by minus 1, which will leave us with a minus 2. That, guys, is the answer for question 1 from our homework examples. Right, question 2. Question 2 was 180 degrees, tan of 180 degrees minus beta, cos of 360 degrees minus beta, cos of 90 degrees plus beta, divided by the cos of 90 degrees minus beta times the sine of 90 degrees plus beta. We apply the same steps as always. We first begin to identify which quadrant do we find a 180 minus beta. That is our second quadrant. And tan is negative in the second quadrant, and so that translates to minus tan beta. Let me make my minus more clear. Right? Which quadrant is this 360 minus beta? This is in the fourth quadrant. And what is cos in the fourth quadrant? Cos in the fourth quadrant is a positive. So we say cos beta. Lastly, we have a 90 plus beta. 90 plus beta, remember we had said on our Cartesian plane that this is the second quadrant. Second quadrant is where sine is positive. So cos is negative in the second quadrant. That's the first step that you remember, right? The second step is we are working with a 90 degree. So ding, 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 immediately cos co-function. The co-function for cos is sine. So that will be a sine beta. Right? Below the line, we have our 90 minus beta, which is quadrant 1. Quadrant 1, all angles are positive, and so this will be again alarm bells. 90 degree co-function, it will be a sine beta. Here we have another quadrant 2. This is quadrant 2, and it is expressed as a 90 plus as opposed to a 180 minus. We know when there's a 90 degree, we use the co-function, and in the second quadrant, sine is positive, so we keep the positive and we change the to the co-function, which is sine of beta. Right. Second step looks something like that. So already from here on out, we are able to eliminate your cos against cos. That will give you 1. Sine against sine will give you 1. And also we have a minus multiplied by a minus, which leaves us at a positive. Right? And from there on out, our final answer is 10 of beta. So I know what some of you could have done here. You could have taken tan beta and then expressed it as sine beta over cos beta. You would have done that and you would have still had to, or you would have still ended up reversing back to the same conclusion by virtue of principle of how they would, your numerators and denominators would cancel against each other. As I said, any questions in the Q&A section for me, please, and I'll get back to that. This, as your reference point, is question 2 of the homework questions. Question 3, we are simplifying again. Standard rules remain. We are simplifying sine of 90 plus beta, sine of minus beta. Here's a little special angle that I discussed with you guys a few minutes ago. We have tan of 180 minus beta, cos of divided by the cos of 360 minus beta times the sine of beta minus 180 degrees. Hoping none of you thought this was an error. It's definitely not an error. We have a swap around from what we usually see. Right. So our usual steps. Which quadrant does a 90 plus fall in? It falls into the second quadrant. Our next step, we are talking about a 90, and so we need to apply the co-function rule, which then says that we will replace sine with cos. Remember, sine is positive in the second quadrant, and so it's going to be a positive, and we're going to call it a cos beta. Right, and then we have a sine of minus beta. As I had indicated to you that a sine of minus beta almost suggests that there's a 360 degree angle in there. At 360, sine is negative, and so we'll have that as a minus sine beta. And then we have our tan of 180 degrees minus beta. 180 degrees minus beta is in quadrant 2. Tan is negative in quadrant 2, and so that's where we get that from. Below the line are 360 minus beta. It's cos of 360 minus beta. Oh wow, it's the cos of 360 minus beta. This is your fourth quadrant, and cos is positive in your fourth quadrant, so you keep that as a cos of beta. And here, ladies and gentlemen, you could, if you're comfortable, you could just look at it at one go and be able to say that you'll take out the minus, you'll swap everything around. But if we take it step by step, I would say to you, if we pull out our minus from the bracket in order for us to swap around, we take out this minus and we put this 180 first. Let me use a different color pen. We take out the minus and we're going to use it as a multiplication factor. And we're going to take this 180 and put it first. So if you take out the minus, so it's really the equivalent of dividing by minus. If you take out the minus and you bring it out, you take your 180 and you put it first. Your 180 is now positive. When you divide a negative by a negative, it becomes a positive. There we go. We have our 180. And then we have our beta, which is currently positive. So if you divide it by the minus that we are referring to, a positive divided by a negative brings us to a negative, and so that will be negative of beta. And already it looks very familiar to what we are used to. So here is our step, our first step, where we would take out our negative so that we are able to write our formula or our function in a way that we know best to reduce. From here on out, it becomes much simpler. We are able to identify this as belonging to the second quadrant, where sine is positive. If sine is positive, you're going to multiply by plus, the multiplication with plus sine beta. There is our next step, guys. And our negative here remains unshaken. So for example, if this was a sine of 180 degrees plus beta, at 180 degrees plus beta, which is quadrant 3, sine would be negative. And so you would almost need to take out another negative to be able to say minus sine beta. In that case, you would be saying minus 1 times minus sine beta, which would then give you a positive. Hoping we're good and well, that makes sense. Happy to take your questions in the Q&A section. Point of reference, question 3 of the homework questions. Right? From here on out, it gets simpler again. We are cancelling cos over cos. We are cancelling minus sine beta over minus sine beta. And we are left with a minus tan beta as our final answer. Simplified answer. Remember, this is question 3 of our homework questions. Right. Our last homework question was a bit tricky. We had quite a few swap arounds. Oh, we had only one swap around. It was just the dramatic swap around. And this in itself also looks like a swap around. So from here on out, we do the usual steps where we recognize that this is quadrant 3. Actually, let me reverse. If you're quite quick and if you've been practicing, you will begin to recognize from afar that this is quadrant 3. If not, and you want to see what you are familiar with, you will want to convert this to a 360 minus beta. How do you do that? You take out your minus so that you have your 360 in brackets. And then to make this beta positive, where there's a negative outside, there's another negative. And again, this is looking like quadrant 4, right? For the meantime, I kept 1 unchanged. For tan, where we have tan of minus beta, remember I'd said to you minus beta is the equivalent of there being a 360 here, and 360 minus beta is quadrant 4, where tan is negative. So you will have a negative, the minus the tan of beta, right? Then we have your cos of minus 180 plus beta. Again, if you're quick, you will catch that this is actually the second quadrant. We're not always that quick. It'll take practice to become quick. You will begin by taking out your minus, and so that you are left with 180 degrees minus beta. And then it begins to look familiar, or you'll write it as minus cos of beta. The same rule applies here, where you will take out your minus and you will recognize that this is minus 180 minus beta. All right. From there, we know that we will apply our usual reduction rules. I deliberately left this in, guys, very well aware that whenever you square a negative, you are multiplying a negative by negative, and that turns it to a positive. Deliberately left it in for the current step, just so we could focus on, just so we could focus on reducing. At this level, we know that cos is positive in this quadrant, and so we have cos squared of beta, and we keep our 1 for now. I always say if you have a number, keep a number per step until you can see that you need to convert the number, especially where the number is added or subtracted. I think numbers that you divide or multiply are easier to work with, but where you have a positive or a negative, you take your time, you slow down, and you keep it in there, right? So we have here, from there we have a minus cos beta, which came from this piece over here, because this plus is going to turn to a minus when we move this minus out into there. And then from here, as I said to you, this is how you could write it, and so you can recognize that over here is actually the second quadrant where cos is negative, and over here is the second quadrant as well where sine is positive. What does this mean? It means that we keep our 1, as I said, we keep this. I'm about to square it in the next step. We were just aiming to reduce it. We've kept our tan beta. Here we say, if your cos, so you already have a minus, a standing minus here. The minus that you first took out when you were changing this into a visibly reducible formula, right? So now you have that 180 minus beta. Again, you will take out a minus because you know that cos is negative in your second quadrant. And when you do that, you have a minus times a minus, which then gives you a plus cos beta. Here the same applies and is true. We have a minus sine beta. So we've already taken out a sine and we are left with a second quadrant. Positive, cos sign is positive in the second quadrant, so that simply becomes sine beta. No negative to multiply by, and so this negative still remains. Hoping that makes sense. All right, and then from there, I then moved on to my usual rule to you guys to say, always try and simplify and express tan as a sine and a cos function. First, now I've eliminated our minus cos, and I've written it correctly as minus or as cos squared beta. As from there, we have our plus 1, and we have now changed our tan. We switched our tan up to a sine and a cos function, and we've left these two to remain. From here, we've really simplified the formula, and we can quickly begin to see that this cos is a denominator that can be taken out against this numerator. When we do that, then we can see that what remains up top, we have a minus sine beta times a sine beta. So you have a cos of square beta plus 1 minus sine beta times the minus sine beta. How does that look? It looks as follows. It's your cos squared beta plus 1 minus sine beta times sine beta. And that's what gets you that. Right. And then from here, you take your minus times your minus, and it becomes a plus. Remember, guys, I just wish to emphasize that what we've done here is absolutely, I'd like to change pens again. What we've done here is not the same as what we've done here. In this particular case, from your starting point, the entire square applies to the whole bracket. This simply, we express it in this manner, and so I would understand why you would question why it's not the same thing, but the entire square applies to the whole bracket. This bracket over here is the equivalent of saying cos of beta minus 360 times the cos of beta minus 360. Whereas over here, what I'm saying is sine beta, which is this over here, sine beta multiplied by minus sine beta. So there is definitely a squaring of the sine betas, but you are multiplying a negative and a positive, and that's why you keep your negative. Please, guys, these two are not the same. They may look like they're written the same because from an expression point, that's how we express it, but they are not the same, right? From here on out, we have a minus against a minus, which translates into a positive, and almost immediately we can see one of our Pythagorean identities, cos squared beta plus sine squared beta is equal to 1. So this translates into a 1 plus 1, and your final answer is 2. Reference point is example 4 from our homework questions, guys, if you have got any questions on this one. For today, someone had said to me, Ma'am, you've been using beta and theta for a while. When do we begin to use numbers? Here's one example, and I've given you a link with more practice examples that you can use. For today, we will be simplifying this using numbers, actual numbers, and not betas and thetas. So we're going to simplify the cos of 300 times the tan of 150 degrees divided by the sine of 225 degrees times the cos of minus 45 degrees. Starting point, guys, we are able to see how we need to apply our reduction formula. Here we rewrite this using our reduction formula. We have 360 and so how do you know what to use? So how do you know that we are going to use 360 minus 60 here as opposed to 180 plus 120? You look at so remember I had said to you, beta is an acute angle, and so you look at the smallest beta that you can subtract in a particular quadrant. I know that makes sense. You'll catch it as we go along. All right. So this here sits in quadrant 4. You will split it into quadrant 4. You will express it as a quadrant 4 reduction formula. 150 sits in quadrant 2. We'll express it as a reduction formula of quadrant 2. Sine 225 sits in quadrant 3, and you will express it as such. And as, remember what I had said, I'd said to you, where you see a minus theta, you assume or you know that there was a 360 degrees before that. You have made a full revolution. From here on out, you apply your usual reduction rules where 360 minus this could be beta. 360 minus is actually positive in the 4th quadrant, and there you have it as a positive. 180 minus is the 2nd quadrant, 10 is negative in the 2nd quadrant, and there you have your negative. 180 plus is the 3rd quadrant, where sine is negative, and there you have your negative. And 360 minus is your 4th quadrant, where cos is positive, and there you have that. From there, remember this table, this was in lesson 1 and 2. So we started with the table here where we simplified everything. We used our right angles and we got to these numbers as our special angles. Remember guys, 60, 30, 90, 45, 45, 90. Those are our right angle triangles with special angles. And when you have special angles, you are really able to translate your data into numbers. And that's what we've done over here. Cos of 60 is a half, then 10 minus 10, 30 degrees is minus 1 over root 3. Same applies to our numerator, our denominator, where we multiply accordingly. And from here, remember guys, this is going to be minus 1 over root 3 times 2. I know I'd always say to you, always try to remove the root from the denominator, but we're not at the final stage, and so we don't do that yet. A root times a root actually eliminates the root, and that makes things easier, right? So here you can see, guys, we are dividing a fraction, this is our divisibility point, by a fraction, which is the equivalent of multiplying by the inverse of the 2nd fraction. Your 2 and your 2 will eliminate each other. Your minus and your minus will eliminate each other. And we are left with 1 over the root of 3, which you could express as the root of 3 over 3 if you multiply by root 3 over root 3. You would do that to eliminate the root in there. Alright guys, this is today's practice example. We have a second practice example, but I am cognizant of time, so I'll move a little bit quicker on here. Again, questions if necessary. We have our tan 150. 150 is in quadrant 2. We have cos of 390. When we have cos of 390, think about it on our Cartesian plane. It means we have 360 plus. And if you remember those rules that we had set up, 360 plus actually falls into the 1st quadrant, because at 360 you have gone full circle, you've done a revolution, and now you are starting over. So a 390 is a 360 plus a 30. So you are sitting 1 revolution in and 30 degrees into the 1st quadrant. So this is the 1st quadrant, right? And we have here a minus 2 times the sine of 510. Again, you apply the same rule to 510 to say, how does 510 come about? 510 is equal to 360 degrees plus 150 degrees. Then you have a moment to say, oh, right here, our beta or our addition is still greater than 90. It's still not an acute angle, and so you will have to reduce further. Right, so here, this is what I meant when we write it out step by step. 2nd quadrant is your 180 minus, and you have there a 30. This, as I said, is your 4th quadrant where you have a 360 plus 30 and you have cos. This you keep unchanged, and you see that you still here do not have an acute angle. you always try to take your beta or your alpha to an acute angle. An acute angle is an angle that is of less than 90 degrees. Right. So then we take that and we do our usual reduction. Second quadrant tan is a negative, right? First quadrant cos is a positive, and we reduce our 150 further here to a 180 minus 30 degrees. Ding, 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 we are in the second quadrant. We have reduced to what looks like a familiar reduction formula. From there on out, we know that sine, this is the second quadrant, and sine is positive in the second quadrant, so we keep our positive, and so this negative also remains, and that's what we have. From here, we go back to, we can see our special angles over there, and we are going to substitute this using our special angles. We have tan of minus tan of 30 degrees is 1 over root 3. Cos of 30 degrees is root 3 over 2. You subtract 2 times the sine of 30. The sine of 30, ladies and gents, is 1 over 2. This 2 over here is this 2 over here. Right? You simplify that mathematically, you're left with minus a half minus 1. Minus a half minus 1 is a minus 1.5. And that is how you simplify it. That is how you answer your question when you have numbers. Number 1, the rule, the instruction could be do without a calculator. When you say do without a calculator, this is what we mean, leave in third form or the like. Sometimes we'll say to you, simplify and express is the simplest function. And that means that at this level, you will not apply your numbers. You will leave it as a function, which is sine, cos, or tan. Hoping that all makes sense, guys. As I said to you, I've attached the links that you guys can use for practice examples. I'm big on the quizzes on Khan. The Siyavula link, there are 2 Siyavula links. The second Siyavula link is literally the textbook. I'd like you guys to please look at that. What I'd like to start doing as we go towards the end of the trigonometry portion of the syllabus, I'd like to be able to refer to the textbook, to refer you to the textbook for us to do some practice examples. Right? What will we be doing next? We'll be doing double angles and half angles, and we'll be solving trigonometric equations. Just from here, guys, I need you to brush up on your functions, your memory of functions or what you've learned from functions. Small revision as we prepare to move forward. Okay, this is my last 10 minutes, and I'd like to find out, are there any questions from our Q&A section? Let's see if we can source the questions. Can I view the questions? Oh, guys, this is our contact information. This is where you get a hold of us, Africa Team Geeks. This is all our information. You guys have my Twitter handle. It's at _Mbali cap MCAT. Sure, it's not a fuss. I am Miss Shabalala, and we'll be back again tomorrow to address any of your questions, guys. Let's see. We do have a question. So it says in the first question, I don't understand how cos became a sine. Right. Let's go back to our first question. You don't understand how this cos became a sine. When we work with 90-degree angles, we apply what is known as the Coe rule. What the Coe rule is that it says, let me just find a pen. Right. I suspect you are referring to this becoming that. Right. When we work with a 90-degree angle, whether it's 90 plus or 90 minus, we have what is referred to as the Coe rule. The Coe rule says when we work with 90, we are going to reduce and change your function to the Coe function. Mathematically, I can prove to you what that means, but it's basically the application of the Coe rule where you have a 90 and so it converts to the co-function, which is sine, right? If you could please go back to one of our lessons from last week, I believe it's lesson 2, and again it's reiterated in lesson 3, the application of the co-functions, the application of the co-co rule. That is where it comes from. We can quickly mathematically apply this using a special angle. Let us say beta is equal to 60 degrees. How you would then translate it is that you would say this is the equivalent of saying cos of 90 degrees minus 60 degrees, which is equal to the cos of 30 degrees, right? But then again, remember I said beta is 60, right? Well, the cos of, let me rather do that. My thing is frozen. Okay, wait. Okay, found my mouse. So remember that from our special angles, the cos of 30 degrees is equal to the square root of 3 over 2. It's your adjacent over your hypotenuse, right? So if you had to write this as the co-function, which is sine, you would substitute this with the beta, which is 60. So you would say sine of 60. The sine of 60, guess what, from our special angles, is the square root of 3 over 2. In this instance, it is actually opposite over hypotenuse. This is why, at a very basic level, your sine and your cos are co-functions of each other. So your co-functions are sine to cos and also tan to cot. Cot for cotangent, right? Those are your co-functions. The co-co rule, your co-functions, sine to cot and cos, sine to cos and tan to cot, and equally the other way around. Always the rule was that we had given was you apply the co-co function where you see a 90-degree reduction. That is the answer to your question.
5 minutes to end of session.
Right, guys, that is the end of our session for today. As I had said, let's do some practice example, guys. Let's look at the Siyavuya text, Siyavula textbooks. Let's read up. We are moving towards the peak of trigonometry, and just please refresh yourselves, guys, on functions, because from tomorrow when we start solving trigonometric functions, trigonometric equations, we'll be looking at functions. Yes, if there's nothing else, guys, this is the end of the lesson. Enjoy your day. I'm Ms. Shabalala. As I always say, please stay healthy, stay hydrated. Whatever religious activity you have, do that. Remember, we are all in a difficult time. It's lockdown. So be nicer to people, be nicer to yourself, and take care of your peace of mind. Thanks, guys. Bye.